next week. All right, let's get started. Okay. All right. So last time I think we talked about before the midterm exam we talked about stereoscopic display, right? How you display 3D images to the user. So this is one of the original design of the virtual reality system by a scientist called Ivan Sutherland from MIT. So you see, this is his original design back in 1965, and we've been using the same design for virtual reality, more or less the same design. So it consists of two displays right in front of his face, all right, and it also consists of a position and orientation tracker, which keeping track of the position and where the user is looking at, the direction that the user is looking at. It is a mechanical system. You can see that the purpose of this device is to estimate the x, y, z coordinates as well as the position of the head that it is pointing at. And then there's electronic device that's up there that's generate the computer graphics, and that is being fed to the display in real time, basically. All right. So, and we've been using the same design and same setup for virtual reality system design up till now. So, a typical VR system consists of three components right now. One, it is a position and orientation tracker. Two, is a head-mounted display. And three, is a computer that generates the computer graphics. Okay. So, first of all, there is a position and orientation tracker. And it is keeping track of the position, x, y, z coordinates. And the orientation, we call this yaw, pitch, and roll. So it's free orientation in position and free orientation in orientation. Yaw, pitch, and roll. Okay? So it estimates the direction that the user's head is pointing to. And we are keeping track of the position and orientation in a very fast fashion. So we're talking about at least 30 hertz. All right. So 30 times. The position and orientation is updated 30 times per second, at least. Okay. And we feed these we call this 6 degrees of freedom because we're getting 6 parameters each time that we are updating the position and orientation. And we feed these position and orientation information in the computer. Okay. The computer, based on these 6 parameters, generate 2 pictures, one to the left eye and one to the right eye. And we do this in a very fast fashion. Okay? And as you can imagine that our eyes and our brain are very sensitive. Okay? We are very sensitive to motion. So time to time again, you may run into a situation when you move your head too fast, that your computer is still in this position, and you are looking into that position when you move around. Okay, so that's basically generating a view that is kind of shaking and wobbling and following your position. So basically the computer is not able to keep track of your motion. And that is generating a phenomenon we call simulation sickness. Okay, so basically after a while when you take in your virtual reality head-mounted display and move around for 2 or 3 minutes, then you start feeling sick. You're trying to throw up and get dizzy and things like that. So this is a phenomenon that we call simulation sickness. Okay, so it is primarily due to a lag time. So the computer is not fast enough, and the tracker is not fast enough as well. So that it is displaying information fraction of a second before you move your head. Okay. All right. So there's a couple of administration items. So first of all, there is a modification of course schedule. So originally, we scheduled that there's no class on the May 24th, and there's this change of my own research schedule, so we are going to have class on the 24th, but we're not going to have class on 31st of May. Okay, so it's just a swap between week number 12 and week number 13. Okay, So it is already updated on iCampus and on the syllabus as well. Okay? So some of you asked about the midterm exam. We will distribute the midterm exam next week. Okay? We have about 180 students in this class, so we're still working on grading on the midterm exam, and we'll finish up sometime during this week, and we'll distribute it next week, okay, next Friday, okay? All right, so this is what we're going to talk about today. We're going to talk about one thing, list, okay? Before that, we got some conceptual or theoretical issue, which is called data abstraction, that we'll explain in a bit. Okay, so if you remember, we talked about abstraction in lecture 3. Okay, abstraction is a process of removing unnecessary detail. Okay, you keep what you need, and you remove the information that you don't need. You preserve information and properties that is relevant to the problem. Okay, we talked about that in lecture 3 already. So here we're talking about data abstraction. The process of data abstraction is dealing with turning information of a problem into data. How do you turn information into data? And in this process, there is a process called data abstraction that is in the process of turning the information into data by getting rid of the things that are useless, but keeping the information that is useful. Okay, so in this process of data abstraction, you get rid of things that are not useful, unnecessary information. The data should represent all the information that is required to solve the problem. Okay, so this is a process we call data abstraction. This is an example of a data abstraction. We want to represent a rectangle. Okay, how do you represent in a rectangle? Simple. A rectangle can be represented by two numbers, the height and the width. Okay, so this rectangle can be represented by 2 and 3. This rectangle is 5 and 2. This one is 1 and 4. Two simple numbers. So you keep the information that is useful, which is the dimension of the rectangle. And you get rid of the information that is not useful, such as the color of the rectangle. It may not be relevant to your problem. You don't need the color information. You don't need the border. The border is black. And sometimes you don't need the position as well. So it depends on your problem. So you get rid of the information that you don't need, and then you keep the information that you need. Okay? So if you want to calculate the total area of this free rectangle, basically you just calculate by 2 by 3 plus 5 times 2 plus 1 times 4. And so on. So it depends on what you want to do, the problem that you're trying to solve. You keep all the useful information, and you get rid of all the information that is useless. Okay? This is another example of data abstraction. We want to represent a student in the computer using computer information. Okay? So, and we want to represent all the useful information, such as student ID number, the name of the student, gender, year, and the GPA. So student A can be represented by 1, 2, 3, 4, 5. Five data in here. So this is a string. This is also a string. This is a character, which is the string of one length. Okay, an integer, and then a float point. Okay, so you represent one student using 3 string, 1 integer, and 1 float point. Okay, and once again, it depends on what kind of operation or what kind of objective you're trying to achieve. So you may want to calculate the average GPA. So you just basically add up all these and then divide it by n. The number of male in this class, you count the number of m in this row. The number of year 2 student, and you count the number of 2 in this row. All right. So what kind of operation that you want to do determine what kind of information that you want to keep and you want to get rid of. So this is the general idea of data abstraction. Okay? So far, we learned that there are 2 major kinds of data type in Python. Number literals, right? Integer and float. And then the second kind, string literal, which is basically a string of character. So those are the 2 major kind of standard data type that you use in Python. So it turns out that you can create new data type. So what if we can create a new data type called rectangle, or a new data type called student that represent information of a student? So instead of saying, x equal to 5, can we say x equal to the name of the student and the ID number of the student and then the year of the student and so on? Can we create a type like this? And this is a student type. Okay? So here we introduce a concept called list in Python. List is a compound data type. There are 4 kinds of compound data type in Python. Today we're going to talk about lists. Sometime later we're going to talk about the other 3, which is dictionary, sets, and tuple. Okay? So list is a collection of variables. So a list is a number of variables that we put together. It is a collection of variables for us to put many values in one single variable. So list is one single variable. In this one single variable, it consists of many values, okay, many variables. So this is a list. This list consists of 3 strings, okay? All right, it carries many values in one variable. Okay, so there are lists of different types. This is list of integer. So score equal to 3 integer. Okay, list of flow number. Okay, working hours equals to these 3 flow numbers. List of character string. A list consists of 3 characters string. Okay, and this is how you create a list. You use square bracket. Okay, you can also create an empty list. Okay, a list that consists of nothing. Okay, all right. So formally speaking, Python lists are ordered sequence of items. Well, the key word here is ordered. That means the order, the position of the item is important. So if we have a list called 1, 2, 3, and if we have another list called 2, 1, 3, they are not equal because the order is different. Okay? So lists are ordered sequence. The position of the item is important. Okay? So we declare lists using square bracket. So you can declare a variable called a, and then you use a square bracket, and then you put your information in there. So it could be numbers, 1, and then you separate each item using a comma, 2 and 3, and so on. So this is how you declare a list of number in Python. And you can reference to the individual item just like what you did in string. So list is very similar to string. Okay? So most of the operation that you can perform on a string, you can find some of the equivalent operation in list. So item number 0 is 0. Remember, in computer science, we use a zero-based system. The first item is 0. So you reference as 0, just like you reference the string. If you remember, we can say name equals to John, right? Then name 0 is J, right? Name 1 is O. Okay? Similarly, here, S0 is the first item, S1 is the second item, and so on. All right? So these are the property of lists. List is an order sequence of Python object. Okay? List objects can be of any type. You can create number lists. You can create string lists. Okay? Objects in the list can be heterogeneous. Heterogeneous that means different type. So you can create a list that consists of both number and string. So you can say A equals to 1, 2.3, and then A, B, C. Okay, so that is a heterogeneous list. So that is a We call this homogeneous list. All of these are integer. Okay. So they do not have to be all of the same type. All right. So this is quite different from C if you know C programming, because in C all the list has to be in the same type. Okay. But Python is different. Python lists are dynamic. They can grow and they can shrink the size. Okay. The size can grow and shrink. And this is also different from C. In C, the size of a list is fixed. But Python is different. You can grow the size and you can shrink the size on demand. Okay? Constructed by writing them enclosed in square brackets, and items are separated by commas. So those are some of the examples of declaring lists. So this is a list of 3 items: string, number, integer, and string. This is a number list, and this is a string list. Okay? List operators. It looks all similar to you. I mean, it's familiar to you because this is basically very similar to string operation. You can add 2 lists. You can multiply the list. You can do list indexing. You can get the length of the list, and then list slicing. Okay? And then this is membership, similar to string. So if you have a list, let's say x equal to 1, 2, 3. You can say x item 1 to item 2, slicing. You can leave it open, right? X from the beginning to 2. So the exact same thing that we've been dealing with string, okay? And you can do like x plus x or x times 2 and so on by doing, by concatenating. That concatenating means joining, right? And repeating. All right. So those are some of the examples. You have 2 lists here. List 1, S1 and S2. Print S1 plus S2. So this is joining 2 lists. So you have 1 list that consists of a joining, a concatenating of both of the 2 lists. So multiply S1 by 2. So S1 and S1 again. So this is 1 list. Okay? The length of S1, 3 items. The length of S1 plus S2. So that's 6 items. Okay? Item 0 of S1 is 1. Item 2 of S1 is 3. Right? From 0 to 2. From 0, this is 0, 1, 2. From 0 to 2, but not including 2. That is 1 and 2. Okay? From 1 to 2, but not, this is S2. From 1 to 2, but not including 2. This is 5 only. Okay? All right. Membership. 1 in S1 is true. Right? 1 is here. 4 in S1 is false. 4 is not in S1. 4 in S2 is true. 4 not in S1 is true. And 1 not in S1 is false. Okay? So exactly the same thing that you did in character string. All right. Nested list. Nested list means list in a list. So you can use a list as a member of a list. So this list consists of 2 lists, okay? And the first list consists of 3 items. The second list consists of 3 items. And this is how you reference to each individual item. So student 0. So first of all, this part. This is 0 and 1. So student 0 is this item, okay? And then item 0 of student 0 is this item here. All right? So that's why this is 83. So now, let's try the other one. Item 0, 1. So this is 0, 1. So this is 0, and item 1 is this one, 94. Right? Item 1, this is item 1, and then item 2 in here, this is 0, 1, 2. So this is 91. Okay? This is a list of a list of a list. So you see there are 3, well, first of all, This is the first list, which consists of 2 items. This is the first item. This is the second item. You see? Right? And so this is item 0 and item 1. Okay? In item 0, it consists of 2 items here. All right? So this is 0 and 1. And item 0, this is 0 and 1. So 0, 0, 1 is 43. Okay? 1, 1, 0 is 34. Okay? So this is how you reference to an individual item in a nested list. Okay? So you can form a nested list that has a different dimension. So it does not need to be consistent. I mean, the number of items does not need to be consistent. Okay? Here you have a list. A list consists of 3 items. 1 item, 2 items, and 3 items. Okay? So first of all, 0. So this is 0. 2, 0, 1, 2. So this is 6. Okay? This is first of all 1, and then item 0 of 1. This is 2. 2, this is 2, and then 0, 1, 2. 3. Okay? So if you do a var 1, 1, and 2, so this is 0, 1, 0, 1, 2, then you got an error. Right? Out of reference. Okay? So similar to character string, one again, you cannot reference to, you can slice out of order, but you cannot do a referencing that is outside of the boundary. Okay? So similar to character string, you have a number of functions that you can operate on list item. So if we consider we have 3 lists here, okay? A list called team, a list called words, and a list called nums. So this is the length function. The length of words is here, is 2. Okay? The maximum value of nums is 10. Okay? The minimum value of nums is 4. Sum nums. So add up all these numbers. Actually, I think this is wrong. That should be 24. Right? Yeah. So the total, the summation of all items, that should be 24. So count the number of occurrence of 5 in these lists. Okay? 1, 2. Okay? Get the index of this item from this list. So this is 0, 1, 2. Okay? All right? Reverse the order of this list. Okay? This is the list, you reverse the order. Okay? So if it is 1, 2, 3, then if you do let's say x equal to 1, 2, 3. If you do x dot reverse, then the result would be 3, 2, 1. Okay? All right. Clear. So clear this list. This is the list. All right? So make it into an empty list. So delete all the item in this list, basically. Okay? Append this number to this list. So this is the list. So basically, append this number. Right? Extend. So there's a difference between append and extend. Append one item. Extend is kind of joining the 2 items. Okay? So num, extend this. That means attach. Well, originally, let me undo this first. All right? Originally, the list looks like this. Now, extend. So that means add 1 and 2. Okay? So basically, this is exactly the same as num plus the list 1 and 2. Okay? delete an item. Okay, remove an item from the state index. That means delete item number -1. Okay, so this is the list. Item number -1 is this one. Okay, so delete this item. The resulting list is this. Okay, remove the first occurrence of an object. Okay, so remove this item from this list. Well, let me undo this, clean this up. Okay, remove the item 5. There are 2 5s in this list. Remove the first occurrence. So this is the first occurrence. So remove this. The resulting list is 10, 4, and 5. Okay? Insert an item into this index. Okay? Well, let me clean this up first. So insert the string rank in position 1. Okay, so this is 0 and 1. Position 1, insert this item in there and put this in the next one. Okay, so the resulting list will be spam, rank, and knee. Okay, all right. Addition and repetition, you should be familiar with that. Okay, all right. So I don't expect you to memorize all this, but you need to be aware that there are some operation, there's some function that is very convenient for you to deal with different kind of list operations. All right. So this is an example of a program. In this program, we ask the user to input 5 grades as input. We display the average of the number after dropping 2 lowest grade. So this is what it looks like when you execute the program. So you ask the user to enter 5 numbers. And then you put it in a list. So the list will be 85, 89, 77, 82, 95, and 81. You drop the 2 lowest score. This is a 2 lowest score. So basically you need to get rid of this and this one. And then you calculate the average. Okay? So this is the source code. First of all, create an empty list. All right. Ask the user to enter a number, convert it to float, and assign it to it. Append this to this list. Okay? Do it again and append this number to the list. Do it again and append number to this list. Do it again, append the number to the list. Do it again and append the number of the list. So right here, you will have a list which consists of 5 numbers, which in this case, this is 89, 77, 82, 95, and 81. All right? So find the minimum value inside of this list and assign this value to minimum grade. In this case, the minimum value is 77. So minimum grade equals to 77. Right? Remove 77 from this list. Okay? So this operation will get rid of this number. Okay. And you do this again. Find the minimum value from this list. The minimum value right now is 81. Now, remove 81 from this list. Get rid of this, right? Okay? So finally, sum of the list, adding up all the 3 numbers. Length of the list is the number of item. Okay? So add the 3 numbers and divide it by 3 and then display the result. All right? Okay? All right. So it seems pretty straightforward to me. Okay? The sort method. So this is an interesting function. The sort method, arrange it in order. Okay? So if you have a list that looks like this, when you apply the sort function to this list, it's going to change the order. All right? So G, J, and S, okay, in alphabetical order. Okay. What if you have Joseph, John, and Jane? They're all J. Which one is smaller? If they equals, then you look into the second character. So Jane is the smaller character string. Now O, and this one is O. All right. Next, you look into the third character. So John is smaller than Joseph in this case. Okay. All right. So this is a pair of functions that they do something that's similar, but in the other way. Split and join. The split function turn a string into a list. Okay? A join function turn a list into a string. Okay? So this is an example. The split function string to a list. Split function turn a string into a list. Okay, so if you're a string called A, B, A, C, A, D, it's going to turn it into a list, which it depends on how you split them. Okay, so this is how you split it. You have a string here. Split it using this as a separator. Okay, so this will turn it into a list called A, B, C. Right? Split it using this character. You can specify multiple characters. So this one, turn this into, once again, actually, A, B, and C. Okay? Split it using these two characters. Okay? If you don't specify anything, then the empty space will be used as, well, space, basically blank space will be used as separator, which including space, tab, new line character, tab, new line character, you know. So in this case, you are separating the character string using empty space characters. So this will turn it into, once again, A, B, and C. Well, this one is an empty space, right? So this will be using as a splitter. So this will also be turned into A, B, and C. Okay? All right. The default delimiter of the split function is empty space. So if you don't include any, delimiter, then the empty space will be used. So in this case, the string is with 3 words. Now, split it according to the default delimiter. So you are turning this into a list called with 3 words. Okay? And then the length of this list is 3 items. Print item number 0. Item number 0 is with. Okay? So when you do not specify a delimiter, space are treated like multiple space are treated as one delimiter. So this one, a lot of space, split it, so this will be turned into a lot of and spaces, like that. Okay, so this one, it is not splitting because you specify the separator as space, and there is no space in this string. So this is a list which consists of 1 item. So you turn this string into a list that consists of the entire string, 1 item in this case. The length of this list is 1. Okay, but if you split it using the separator, now you have a list which consists of 3 items, and the length of the list is 3 items. Okay? The join method. The join method, if you look back into here, turn a list into a string. So it does the other way. List to string is the join method. Okay? So you have a list here. Turn it into a string. Okay? So, and you specify the delimiter up here. Okay? The delimiter is one space. So you turn this into one string to be or not to be, full stop, like that. Okay? Here, you specify a delimiter, which is a comma and then a space. So this list will be turned into snap, comma, space, crackle, comma, space, and then pop. Okay? All right? Well, there's a slightly more complicated issue when you deal with lists. Well, before I explain that issue, I have to explain this theoretical issue in computer science. In programming, usually you have two kinds of objects called immutable object and mutable object. Immutable, that means you cannot change, no change. All right. Mutable, that means you can change it. It is a changeable item. Okay? An object in programming is an entity that holds data. So variable is an object. List is also an object. So variable reference to an object. So when you say x equal to 2.0, you create an object in the memory, and it holds the value 2.0. Variable x is pointing at this location. So variable x is a pointer pointing to the object holding the data. Okay? In case of a mutable object, you can change this value. In case of an immutable object, this value cannot be changed. So if you modify the value of this variable, you will create a new object and then point it to another object. So this is how you change the value of an immutable object. Okay? So it may sound a little bit complicated, but I'll illustrate this with an example. Okay? So you have to remember this. Number and string are immutable objects. Okay? So when you create a number, so you create an object called 2.0 and x is pointed to this object. When you change the value of this variable x, so now you change the value. Since number is immutable, you cannot change it into 3.0. So what you need to do is find another location, create the value 3.0, and then point the location of x to this new object. Okay, so this is how actually happening inside of a computer when you deal with immutable object. Okay, list is a mutable object. That means the value can be changed. So when you create a list like this, now if you delete item number -1, you can actually go into this object and change the value of the object. Okay, so remember, number and string not changeable, immutable. List is mutable. Okay? So, immutable object, when the value of an immutable object is changed, a new value will be created and the variable will point to the new value. For mutable objects, such as list, the value will be changed, the variable pointing at the same location. Okay? So I'm sorry, this has to be something that you need to memorize. Okay, it is a concept that is implementation in a programming language. So now let's consider this code segment here. All right. So we have 3 lines of code. So the first line of code creates an object, which is a list. The second line of code creates another object. The third line of code creates a string, which is another object. Okay. Now, this is the fourth line of code. Okay? Append 7 to this list. So when we execute the fourth line of code, append, right, 7 to the list, we'll get into the object directly and change it Okay? So this will become this. But if we execute the fifth line, modify the value of n, instead of go into here and change it, we can't because this is immutable. So instead of doing this, we are creating a new object and then point n to this new object. Right? Similarly, this operation changed the contents. All right? So instead of modifying this, we need to create a new object and point this to this new object. Okay? Why does it matter? If you consider this list, this code segment here, well, take a look at that. It may not make sense to you, right? List equal to 2 items. List 2 equal to list 1. Modify list 2, item number 1 to C, and then print out list. Now, this is what you got. The value of list 1 is A and C. But you will say that I didn't do anything to list 1, right? List 1 should be A and B. I only modified list 2. I didn't do anything on list 1. But how come the contents of list 1 became A and C? Right? It doesn't make sense. Right? And this is how we explain this. Because lists are mutable. Okay? So when you create list 1, so you create an item with 2 items here. When you execute the second line of code here, list 2 is pointing at the same item of list 1. Okay? So when you modify the item of list 2, you are modifying the item of this one at the same time because they point to the same location. So now when you print out the contents of list 1, you got A and C instead of A and B. Okay? The reason of that, in order to explain this phenomenon, is because list is a mutable object. Okay? So if this is what you should do, okay, instead of doing an assignment operator, you should create a new list using the contents of the list 1. So this line of code, instead of creating a list and point to the same object, you create a new object and copy the contents from list 1 into this new object and then point list 2 into this new object. All right. So if you execute this 4 lines of code right now, when you modify list 2, this is modified. So the contents of list 1 remain unchanged in this case. All right. So when you print out the contents of list 1, you got A and B. Okay? All right. So it's a little bit of, it may not make sense to you, but you have to understand what is a mutable and immutable object in order to explain why this program is behaving like this, which is not you would have expected. Okay? So this is an example. I have a list here. When I create, well, this is basically pointing, so list 1 point to the object of 1 and 3. This line here, list 2, it pointed to the same object. Right? So now modify list 1 item 0 to 4. So change this into 4. Right? Print out the contents of list 2. That would be 4 and 3. Okay? All right? Well, before the midterm, we talked about the for loop. Right? Just to refresh your memory, this is the syntax of for loop, right? For a variable in a sequence. All right? And this is a block of code. And this block of code will be executed x time. And x equals to the number of items in the sequence. Okay? So, well, since we already introduced the concept of list, right here, we used to be using the range function here. Instead of using the range function, you can actually put a list in here. Okay? So you can say for x in 1, 2, and 3. Then this code block will be executed 3 times. For the first time, x equal to 1. The second time, x equal to 2. The third time, x equal to 3. Okay? You can also say, list equal to A, B, C. And then for x in list. And then this is your code segment. Right? So this code will be executed 3 times because there are 3 items in here. For the first time, x equal to A. Second time, x equal to B. Third time, x equal to 3. I mean, x equal to C. Okay? So this is an example. I want to create a program that displays the month whose name contains the letter R. Okay? So first of all, create a list which consists of all the 12 months, January, February, March, April, May, June, and so on. Okay, so let's count how many of them consist of the letter R. This one, 2, this one, R. There's no R, no R, no R, no R. There's an R in here, R in here, and R in here, and R in here. Okay, so for month in months, so this is the list. So this will be executed 12 times, right? If R in month dot lower, so this is membership, okay? If this character is in this, so turn this into all lowercase, okay? And make a comparison. If this is true, then print out the month. So in the case of January, R is there, so print out January. Next time, R is in there, so print out there. Next time, R is a member, print this out. R is a member, so print this out. R is not a member in this, so don't execute this line. And you do this 12 times, and this is the result of your program. Okay? Right. This program replaces the name of each month with this 3-letter abbreviation. So the same thing, month equals to the 12 months, January, February, March, April, and so on. For I in range of length of month. So this is exactly the same thing. I mean, you can either say for I in months or for I in range of length of month. Length of month is 12. Range 12 is basically 1, 2, 3, 4, 5, 6, 7, 8 until 12. Okay? So let's see. Okay, so this actually creates a sequence of, I'm sorry, that should be 0, 1, 2, 3, until 11. Okay, so the first time when this loop is executed, month 0, so this is the first item, equals to month 0. This is strength slicing. Item character 0 to character 3, but without including 3. So this is 0, 1, 2, 3. 0 to 3 without including 3. Okay, so I'm turning this into JAN. Okay, loop back and do the same thing to the next month. So now this is FEB. Loop back and do this the same thing, MAR, and so on. So if you execute 20 times, now jump to here, print this out, and this is your output. Okay? All right. Well, here I'm giving you a list of code segments that I would consider it is quite useful most of the time. Okay? So in this code segment, you are given a set of number, and then print out all the number. So this is the number that you got, 6 number. I want to loop through the whole list and then print out the number. Okay, so this is before. So print out before. This is the line here, and this is after. Okay, so for number in numbers, print out the number. So the first time it executes, it print out 12. The second time, 45. The third time, 23, and so on. And this loop executed 6 times. Okay. All right, so this code segment, find the largest number in the list. Okay, so in this code segment, I intentionally print out the intermediate output of each loop so that you can visualize what actually is happening inside of the loop. So this is the list. Okay, we set the largest so far, a variable called largest so far, as -1. So print out the value of largest so far, which is -1. Okay. For each number in this, so this loop will be executed 6 times. Okay? If the number is largest than largest so far, then largest so far equals to the number. So in this case, number is 12. 12 largest than -1 is true. Okay? So largest so far right now becomes 12. Okay? And prints out. Okay? Loop back, and this is the second time. So now 45 larger than 12 is also true. So we set largest so far to 45 and then print out largest so far. Okay? Loop back, this is the third time, now 23. 23 larger than 45 is false. So don't do this. Print out largest so far is 45. Loop back the fourth time. 84 largest than 45 is true. So now set this to 84. Okay? And then print out largest so far. Okay? Loop back, this is the fifth time. 35 larger than 84 is false. So don't do that and print out largest so far. Loop back again, the last one. 22 larger than 84 is false. Don't do that and print out largest so far. Okay? So at the end, print out the largest number is 84. Okay? So this is a code segment that you loop through the entire list and find out the largest number. So it could be quite useful a lot of time. Okay? So you can just directly copy this code segment for your use. Okay? This code segment counts the number of items in the list. So you are given a list, but you don't want to use the length function. You want to count it by yourself. Okay? So you just basically create a variable called called counter, and set it as 0. So before the loop, you print this out. For each number in the loop, increase the counter by 1. So this loop will be executed 6 times because there are 6 items. Each time that you execute this loop, you increase this value by 1. So at the end, the counter equals to 6. Okay? So I modify this slightly. So I basically include this line of code here, which is printing out the intermediate results. So the first time is 12, second time 45, third time 23, and so on. And at the end, the number of items is 6. Okay? All right. Count the odd number in the list. Okay? So basically, you do exactly the same thing. If you take a look at that, you are looping through the loop, but you add in this code, right? If modulus of the number equal to 1, then you increase the counter, right? So now, instead of counting every single number, you are only counting the odd number. If it is even number, this will not be executed, right? So now, when you count, the number of odd number is 3. Okay? So this is how you count particular items under certain condition. Okay, so you define your condition here. Okay, now you are given a set of number, sum of the number. Okay, so you can use the total function, but if you don't want to use it, now create a loop here, right, and then set the variable of sum equal to 0 first. Every time this loop is executed, add it there, right? This is executed 6 times, so at the end, well, I'm sorry, that should be sum. Okay, so at the end, sum equal to 221. All right, calculate the average. So calculate the average. Basically, you do it. You count. Well, you calculate the sum, and you count the number at the same time. All right. So calculate the sum, and do the counter at the same time. And you do this 6 times. At the end, calculate sum divided by counter equal to the average. Okay, and this is the intermediate result. right? This is a sum. This is a counter. And this is the current number of the loop. Okay? All right. So sometimes it is useful to print out intermediate results so that you can keep track of whether you are doing the things correctly or not. It is useful for debugging. Okay? All right. Any questions so far? All right. So I think that's it. So have a nice holiday and enjoy the sun outside.